Okay, so why did it take off? Why the web, the first wave of the web, why did that take off? Because it was a model that resonated with people. Okay? You find webs everywhere in how we go about our lives, and so web finally enabled us the infrastructure to model that. The other reason it took off is it was based on some simple, ubiquitously implementable, that was a mouthful, protocols. Okay, based on ASCII text. Okay, that was very important because any computer vendor on the planet could do ASCII text. You know, it's like you're not asking much of a computer vendor if you say, "Can you do ASCII text?" Okay, so when Tim Berners-Lee did this, he came up with the right formula, something that worked. Okay, basically that formula was this: take an existing infrastructure, the internet. Before it became the web, it was the internet. Okay. Add a couple simple open standards, HTTP and HTML, and voila, what you have is the next generation infrastructure. And I'll show that pictorially here. Here we go. So the first wave of the web took the pre-existing internet, which was a couple bithead people, you know, sending flame email to one another, added HTML and HTTP, and what you now have is what we call the web. And now that's teenagers, you know, chatting with one another and sending email and pointing at electronic brochures that seem interesting. Okay? So just like anything that's alive, it needs to evolve. The web has been evolving. Okay? So XML, the extensible markup language, has been the biggest achievement in terms of how the web has evolved in the last few years. I'm sure you've heard of XML and are familiar with that. I'm not going to go into details on it. But it was firstly applied to the world of documents. So if XML allows you to describe anything and to abstract anything, the first things that we described and abstracted were documents. Okay, and what, if you will, that's kind of the world of nouns. What we've done in the last 2 years is taken that same capability of XML to describe anything and to abstract anything and applied it to the world of infrastructure, the world of APIs and object models, programming languages. Okay, now if we could describe those worlds, we've described in essence the verbs. Okay. Now if you get nouns and verbs, you can really rock and roll. So this ends up being the best form of integration ever. In a sense, it's like taking language, forgive me for inserting English there, it's a little kind of me-centric, that's my native tongue, and I apologize for that. But it's the notion of taking spoken language that's readable by humans and inserting it into a language that's read by and understood by computers. Now, I came from Novell. Prior to working at IBM, I worked at Novell for 15 years. The first time I heard of the web and looked under the covers to see what it was composed of and saw that it was a bunch of ASCII text floating around, I said, this is not going to work. How many of you can see that I was way wrong? I was way wrong. Okay, but so what you have, though, is the ability, the descriptive ability to insert tags or language or human readable language around machine readable entities, and it actually assists in the whole thing to make it more fluid and moldable to better uses. Okay, that's the essence of why it's the biggest powerhouse of integration that we've seen yet. So you have tags everywhere. A good friend of mine, Craig Burton, calls XML the calculus of the new millennium. There's a book out that indicated that the author of the book believes that in the first 2,000 years, the last 2,000 years, I should say, of mankind's history, that calculus was the biggest single invention. And the reason was because it enabled the world of science to suddenly take off. Prior to the calculus being invented, we only had models of a static world. We didn't have a way to model the dynamic world around us, an ever-changing world. XML actually gives us that same capability in that chaotic world of heterogeneous computing that I talked about earlier. So the result is we can now model the dynamism and change that actually does occur, and it allows for integration. Okay, so now we get to the crux of the talk. That's how web services were born. That's the situation into which they were born. And so the next round of standards, which is allowing the second wave of the web, have come forth in the last year. So the second wave of the web follows the same formula as the first wave. You take an existing infrastructure, in this case, it's what Tim Berners-Lee had done with the web, so HTML, HTTP, and the internet, and add in SOAP, wsdl, and Uddi, and you have now a conversion of the world of documents, interlinked documents, to become the world of interlinked programs. Think for just a second about how big a difference it's made for the world that we have the ability for documents to point to each other across the web. It's changed literally everything in culture and how society actually goes forward. Now, we think at IBM that this second wave of the web will actually have a bigger impact on the planet than the first wave of the web. Why? Because you can now automate. The things that you're actually linking together are live entities. They're programs. They're things that do things for you, rather than just a static collection of information. So this is huge, and this is why the vendors that have been talking about web services are so excited about it. By the way, Tim Berners-Lee talks about the semantic web as kind of the next generation, where the web is going. And he's recently been saying, and web services is an instance of that. That is stepping in that direction of the semantic web. So in the second wave of the web, we take the people-to-people web, and we add some protocols. This is like the earlier diagram I had. In this case, it's SOAP and wsdl. And now you have the application-to-application web. And what this is meant to depict is those are programs, okay, if you couldn't tell. Those are programs running on a computer at companies. Those are companies, the buildings, okay? So it's no longer about just people sending, chat messages and pointing to cool websites and things like that. You can actually get real work done and automate a lot of the things that we used to do kind of manually. That's what this is about. So this is kind of a programmatic web. We're using the same infrastructure that the first wave of the web has used, but now we're enabling that for the world of programming. Okay? So it shifts the focus from kind of human interfaces, or what you'd see in a browser, to programmatic interfaces, or things that you wouldn't necessarily see in a browser that your program, your application might get excited about, that you may not be. This thing's got a little lag in it. Okay, here we go. So there's been extremely fast uptake with this technology. If you look at Java, which is kind of something that recently took off relatively fast, there was a bit of a ramp period before it really took off. And it really wasn't until Java found its home on the server side, where the world really is heterogeneous. And therefore, it's a better fit for something that's a cross-platform technology. It's kind of hard to be cross-platform technology on the desktop, which is not a cross-platform environment. It's very, very homogeneous. Go Mac, but Windows has pretty much got 90 to 95% of that market locked up. So XML then took off very quickly. Web services is also taking off extremely fast. There's an impact on vendors. Remember the vendors I was talking about earlier that got all excited about vendor lock-in and customers weren't excited about it? Now vendors are getting that, whoops, we've got to make some adjustments. So the first wave caught vendors by surprise, kind of blew them back, if you will, on their heels. Okay? And with the second wave of the web, we've all put our heads together and said, wow, how can we actually work together in this space? And now we're leaning into it on our toes, if you will, around standards body tables to work out how do we cooperate. Actually, there's this notion of cooperating and yet competing. A guy named Ray Norda, who was the head of the company I came from Novell, coined the term co-opetition. And that's actually what's occurring in this space is co-opetition. We sit down at tables with other vendors, and vendors that you'll be hearing from in the next 10 weeks, and worked out how do we make this stuff work. So this catchphrase is, we cooperate on standards, and yet we compete on the implementations. That's a good formula for customers, because you get cheaper products and better products as a result. Web services started approximately a year and a half ago, and it started with kind of a snowball being rolled down the hill, if you will. And it was a pretty big snowball to begin with, because it started with IBM and Microsoft. And IBM and Microsoft were, I think it's been very important in the history of why this has taken off, that it be those two companies. Think about it. IBM was the company that had kind of the dominant play in the early years of computing, which then was taken over by Microsoft as being the dominant player as of late. And those two worlds need to interoperate one with another. So you can now take the desktop, which is the current, has been the current place of action, and now move out to the web. The web is where everybody's looking. It's no longer the desktop. And when you move out to kind of a center place, that's something that IBM's very familiar with, a centralized computing model. Okay, and there are a lot of large companies that get that that's important, that IBM's behind this. Okay, but a lot of other vendors have joined in, and it's been something much bigger than just two companies saying, get ready world, this is the way it's going to be, like it or not. We've gone to standards bodies rather than just two companies kind of having their way with the world. What this enables, another way of looking at this is the Visual Basic programmer, of which there are 6 million, okay, can now actually talk to things that were done by Java programmers, of which there are 2.5 million. Okay? Now, there's a growing number of Java, there's more Java people, it's growing faster, I should say, on the server side, because that's so web-centric, Java is. And the Visual Basic programmer doesn't have to learn Java Remote Method Invocation, the RMI. And the Java programmer doesn't have to learn COM or distributed COM, and yet they can interoperate. We're going to show how. So the network effect is that all vendors are jumping in on this next game, and it actually is something that is enabling us as an industry to move forward. Okay? So the vision of web services. First of all, there's this vision that includes the notion of platform independence, programming language independence, and object model independence. What is a web service? You'll hear different definitions from vendors, but we all kind of agree around the nucleus of what this is about. Basically, it's any program that is callable by another program across the web in a platform-independent, language-independent, object model-independent fashion using standard web protocols. So this is a key differentiator from previous attempts in the industry to do integration. The fact that it allows actually customers to have a freedom of choice in terms of what platforms and technologies that they choose today, but probably more importantly is it allows them to take the choices that they made yesterday and be able to integrate those things and kind of protect the investments that they've made in those technologies or products. And probably more importantly, the skill set that their people have. That's one problem in IT, information technologies industry, is keeping up with the ever-expanding set of skill sets that you have to have. Okay? So the net result is it creates a much bigger marketplace. You ask, why are vendors even doing this? It makes a bigger marketplace for every one of us, for vendors, for third parties, for system integrators, for customers, for everyone. So to spell out kind of what we mean by this technology independence, I'm going to give an example here. So on the left side of the screen, I'm going to bring up an example of a server. In this case, it could be a mainframe running the ZOS with a COBOL application and a DB2 application. Those are IBM technologies, in case you didn't know, along with WebSphere, which is our web application server. And of course, running Java on that side. So on the right side, we'll have another web application server that's not using Java. In this case, it would be using Microsoft technology, which is Common Object Model, COM, okay? Running on Windows 2000. So how do we get these two boxes to talk to each other? Well, what you do is you insert a simple layer of new technology that kind of buffers the differences between the two. You put in a web services description language layer of what interfaces you want to publish. And by the same token, the client side that wants to get to those web services would also have a technology kind of independent layer with SOAP and wsdl. And we'll talk about more details about that. And then what you do is you communicate using SOAP between the two boxes. And this is kind of the web service zone. It's almost like a no man's zone. It's vendor neutral. When you step out into that space, it isn't about any one vendor at all. It's about an industry movement. Okay? And all of us are in agreement with this. This is the good thing. One thing that we've learned with the .com, there was the boom, right? And we've just had more recently the .com bomb or bust. One thing that's clear to us at IBM is that e-business still means business. If you can't produce real value as a company, you will disappear. Okay? So, kind of like what Federal Express did to the world of shipping packets and letters around. Clearly, before Federal Express, companies could send an envelope to one another. You could do that easily. But FedEx came and said, I can do it faster and guarantee that it will get there the next day. If not, come see me. So, but what Federal Express didn't do was cause everybody to kind of completely change how they did business. Or it wasn't really a new business. It was something that enabled business to happen faster. Okay? So that's what we're trying to do with web services, and we think that web services is kind of the road out of the dot-bomb crater. So it's about enabling businesses to do business-to-business communication faster. It's definitely not technology for technology's sake. That's part of the reason why technology's gotten away with not interoperating, is because we forgot about the importance of the real business value behind technology. And IBM is one to always keep that in mind. When you think about the early days of IBM, it was typewriters. And that was about automating business. And IBM's been in that business from day one. That's why business is our middle name in the company, International Business Machines. So it's not technology for technology's sake. We'll know web services have succeeded when we no longer talk about it, when we just simply use it. Okay? You don't hear a lot of people talking about HTTP and HTML anymore. Back 4 or 5 years ago, books all over the place. Everyone's scrambling to understand HTTP and HTML. It's like, you can understand that now, but it doesn't really matter. Just use it. Okay? Same thing will be the case with web services. And that's the nature of any useful technology, is it, over time, disappears. It becomes a commodity. And that's something that we as vendors, you'd think that we might be afraid of driving our technology to commodity, because if it's commodity, you don't make money off of it anymore, right? But at IBM, we want to drive it to commodity quicker, okay? Because we think that there's ways of making money with the next generation that's waiting on the heels. So from a business-centric view, web services enables you to basically describe your business. Okay? You can actually describe the functionality or services that you render for the world, and then publish that information so that others can discover the services that you have as a business and connect automatically or from a programmatic perspective to that business. It's kind of like if each company actually had an API, a programmatic interface, a kind of a company API. If you were to look at each company and kind of use object thinking in terms of what a company is an object. And that object has inputs and outputs. And so if we could come up with a model that would describe businesses, okay, and then allow those businesses to connect one to another, kind of like what FedEx did, and in a faster, quicker way, in a more reliable way, would that not be a good thing? Absolutely would. So it's this notion of kind of the vision that we have at IBM of this is integrated business machines. Of course we'd have that notion because it works out to be IBM, right? So. From a software development perspective, I just kind of gave the business view of what web services are enabling. From a software development perspective, it's just the next step in an evolution of how we build software. In the old days, we build one monolithic program that had everything in it. There was no notion of linking in other foreign pieces. And then came this notion of statically linking in a chunk of software that some other poor person wrote that you didn't have to write, and you could include it in your program. But your program got bigger. And then we moved to the notion of shared libraries or dynamically linked libraries where there's that shared code could be used separately. But a single copy could service multiple applications. The next step was kind of saying, well, let's actually have the code exist somewhere else completely, out on the internet or on another machine. The notion of a remote procedure call evolved. The problem with that is it still required that you had to have the same language on both sides, the same object model on both sides of the wire. So web services is the next step in that evolution. It's really not that dramatic. Okay? Neither was what Tim Berners-Lee did, by the way, was not that dramatic. But the impact of it is what is going to be dramatic, unquestionably. So now you're freed up to use code in place out on the web. All right? So what that means is I could, in the future, hold up a Palm Pilot that is actually connected and leverage functionality that exists on the web. It doesn't have to be on this device. This device is just a window to that functionality. Okay? And all I have to do is be able to send SOAP messages. Okay, so we're going to get into that. No questions so far. Okay. What this enables is kind of a new world, a newfangled world where you could actually compose web services out of pre-existing services. So you can kind of convert pre-existing services into something that works with these new set of protocols. But then you could compose web services out of web services. So eventually what you could have is actually where you begin computing on one machine, it sends the payload and the computing data across the wire, and another machine, a middleman machine, does some work on the task, and then passes it on to a third machine. Okay, so this is what distributed computing was meant to be years ago when it was first envisioned. So where will web services be used? They'll be used inside of enterprises, enterprise application integration, also across firewall boundaries from one business to another, or from businesses to consumers. Also in the pervasive computing space, the space of handheld and cell phones, systems management. Basically, all these areas in the industry will be impacted by web services. The sky's the limit. Actually, we can't even forecast where it will be used in its entirety. Not unlike the first wave of the web, we didn't know the impact it would have on the planet. Same thing with this. And with that, I want to put in a quote from a good friend of mine now. I wish I knew him. Peter Gabriel, from the song Mercy Street, great song. All of the buildings, all of those cars were once just a dream in somebody's head. So I like that notion of technology. We all take it for granted. You know, I can do this pointer thing. It's like somebody invented that a long time ago, and I take it for granted now. By the way, hi, Peter. I hope it was okay I made that quote. My good friend. So what are web services composed of? So if a web service is kind of a program that has an interface that's callable across the web, what does that look like? Well, inside of it, what you actually will have is a SOAP router. This is something that's added to a web server. A web server is something that serves up the web, or HTTP. It has an HTTP handler on it. So next in line, down the kind of downstream from the HTTP handler will be a SOAP router, a SOAP handler. Okay? So that's what's added to a web application server, and suddenly it's a web service server. So we actually want to use, it's not just an interface that's callable, but it's callable across standardized XML messaging, or SOAP. SOAP stands for Simple Object Access Protocol. And so it's a further definition would be it's a SOAP interface connected to application processes. That could be thought of as kind of the minimum, but it doesn't really address it. So what we've added in is web services description language. So now it's kind of like in the world of APIs. If you can come up with any API and share it with the world, well, you have to describe it. It's kind of like getting an SDK, a software development kit, that has a list of APIs. So if companies come up with APIs describing how you talk to their services, they need a way of giving you an SDK. And this is a way of giving you an SDK in a nutshell, using XML as a platform-independent way of describing those interfaces. Okay, so wsdl descriptions then assist programmers in getting their job done to actually invoke SOAP services. And then Uddi is kind of added in the background, we'll talk about that in a second, as something that's supportive even further, and how you discover what services exist in the world, and if you have web services, how you publish them and advertise them to the rest of the world. So SOAP, the Simple Object Access Protocol, started out with SOAP 1.0. Userland, Microsoft, and Develop Mentor came up with SOAP 1.0. It was specific to COM and HTTP. IBM heard about this. Our research guys actually saw that Microsoft was doing this, and IBM researchers were doing something very similar. And instead of the classic IBM approach of, well, we'll do it better, we'll ignore what those guys are doing, we actually picked up the phone and called up the Microsoft guys and said, this looks interesting. Would you be willing to make a couple changes? Yeah. What are they? Well, we think that it ought to be, it shouldn't be tied specifically to COM. Sorry. There's another world out there that isn't just COM. We think that you should have substitutable transport bindings, not just HTTP. How about the world of email, SMTP? Wouldn't it be cool to send SOAP messages across email protocols? How about across FTP? Or what about across any message-oriented middleware that might exist, like, for instance, MQ series that IBM has? They said, oh, that makes sense. But we think it will mostly be used by HTTP. And we said, undoubtedly, we agree with you. But let's not lock in this technology. It'll have bigger legs. It'll last longer if you make it flexible. And so they agreed. And SOAP 1.1 was announced and published to the world on April 26, 2000. 2 days later, IBM had an implementation of SOAP done in Java. And we posted it on our website, the cool website that IBM has called AlphaWorks. AlphaWorks is where we display to the world what our research group is doing. This is a new way of thinking at IBM, by the way. There's a very open way. It says, here's what we're doing with the $6 billion of money that we spend on an annual basis on research. Want to come take a look? I highly recommend that if you want to see what's coming down the pipe, go to AlphaWorks. So anyway, we posted that on AlphaWorks, and that was downloadable, and anybody could get this SOAP implementation done in Java and start playing with it. And that was the whole motivation, is if we want this to take off, Microsoft, we have to get it out to the world fast. We've accelerated that even quicker at IBM. By 2 months later, we gave SOAP to the Apache Foundation. How many of you know the Apache Foundation? Open source. This is open source nirvana. And so IBM, the biggest patent portfolio owner on the planet, did something that didn't seem like the biggest patent portfolio owner on the planet. We gave something away. And it's not the first instance of that. We've been doing that quite a lot. So SOAP 1.2 is the current implementation of SOAP. And I've got references on the next chart. But it's moved to W3C. That was the next move, is let's not just be an IBM and Microsoft thing. Let's move it to a standards body so the world can use it. And a working group called the XML Protocol Working Group is who's working on moving it to be an official standard. Okay? And in some ways, Simple Object Access Protocol, the acronym SOAP could be expanded to mean Services-Oriented Architecture Protocol. It's a new way of thinking. It's a way of thinking of connecting up services out in the world. So what does SOAP look like? It's actually an envelope. It's just an XML dialect that specifically is in the realm of describing envelopes. What do you do with envelopes? You put things in them and you ship them somewhere. That's all SOAP is. So if you were to look inside of SOAP, it would look like this. There are these conventions in blue which are actually part of the SOAP namespace convention, and this is what describes the envelope. It also describes things like your binding model, and actually how you save objects, how you serialize objects in a platform and object model neutral fashion. That's the magic of SOAP right there, by the way, the ability to serialize any object from any language, okay, and then unserialize it. And then it carries around this payload, or this message, if you will, and the message itself can have its own dialect of XML. Okay? So that's what provides the real power. So if we look at kind of an example, here on the left we've got a service requester, the internet, and a service provider. You can tell this is a service provider because there's a firewall, and then the HTTP server and a SOAP server. So you send a request across the firewall to HTTP, goes to the SOAP router, and is handled then, carried out somewhere back here by some mystery box. The response is sent back across the web in this SOAP format and received on the requester side. Now what actually is in this box? Well, it could be an enterprise Java bean if you're a Java guy, a Corba thing. It could be a COBOL entity. Or if you're on a Microsoft platform, it could be a COM entity. Now for IBM, our intention is to not put COM on our servers. And that just means it just saves us some work, because we've made an investment in Java working. Java is already our solution for kind of a runtime execution environment that works across many platforms. So we don't need to put COM there. But obviously Microsoft is thinking the other way. Microsoft's thinking in terms of putting an X right there and highlighting COM. That's okay. That's okay, because as long as we got these protocols that let those two boxes talk to each other, it doesn't matter. So on the other end, you could actually have, it was a human that caused this whole thing, this chain of events, or it could have been a non-human, a program. The importance is that across the wire is there some standard protocols that are being used. So it makes these two worlds kind of opaque. You can't see inside. They're more of a black box. So why will SOAP succeed if this attempt has been there in the industry before? Well, Unix RPC was something that was attempted before, but it required the same binary compatible Unix on both sides of the wire, which is a very difficult thing to do. Corba attempted to do this, but it required compatible orbs. The object model had to interoperate on both sides. It also required you to think in terms of IDL. I don't know if any of you looked at Corba, but thinking in terms of IDL meant you forsook, you gave up thinking in terms of your own language, like Java or Visual Basic. RMI, the Java attempt at this, required Java on both sides of the wire. Guess what? Java isn't everywhere, as much as some people want it to be. DCOM, same approach with what Microsoft did. And so SOAP is the answer that's the natural choice. It allows freedom of choice on both sides. You could think of SOAP as an RPC, remote procedure call approach. But That's just kind of a send a request, get a response, send a request, get a response approach. Nickel and diming the world. SOAP isn't restricted to that. You can send whatever you darn well please inside of the SOAP envelope. So you could actually send a big XML document that then someone undoes at the other side of the world and carries out many tasks, not just a single task kind of a thing. The other thing is you can actually include random binary formats using the MIME protocol. So here's a list of resources for your edification you can look at later. I'm not going to go into any details. So this is great that the industry's come up with these kind of standards so that vendors can talk to one another. And that's great for a set of services that might be considered standard. But what if you were doing your company API, which is not a standard? This is just simply unique to your company. How do you go about doing that? Well, the way we made that practical is using this new dialect of XML called Web Services Description Language. Okay? You understand that XML is just basically an alphabet. And then you compose vocabularies out of that alphabet that you agree on by convention, not unlike spoken language. We share the same alphabet, English and German, and yet different words, definitely different grammar. Kid you not. So anyway, XML, the XML vocabulary for this space is wsdl. This is like what IDL was for Corba, but instead it's using XML as the basis. This allows you to actually describe your service interface, some implementation details. How do people actually get a hold of that protocol or access it? What access methods do you use actually, and what are the contact endpoints? Where does the service live? Okay, that's kind of important. You need to engage the service. What's the URL? Where does it live? wsdl is a convergence of two efforts separately at IBM and at Microsoft that we merged and called wsdl. What's interesting about wsdl is it can describe any service using any kind of technology. For instance, the one that we focus on is SOAP as the binding method. But it could describe something that pre-existed as a Corba service. You could use wsdl to describe that. You could use wsdl to describe something that's using distributed COM from Microsoft. So it's not forcing you to use SOAP. Okay, that's kind of an interesting feature. So it also is something that ends up helping you to, as a developer, to not get kind of stuck in the details. If you had to convert everything that you were doing from your language of choice, if it were Java, and convert it to SOAP, you'd be hand converting a lot of code all over the place. Or if you wanted to convert something to a service and publish it and do that yourself, that would be a lot of work. So what we do is we come out with tools, and this is what compiler vendors do, is they make your job easier as a software developer. And so a toolkit will take a wsdl document and then generate the connecting kind of software on both sides of the fence. The service proxy on the client side, or the service implementation template on the server side. Okay, and then you just add your own application-specific code. So no more details about wsdl. There's some further references for you to look up. Any questions so far? I think I should ask for questions. No. You want to get to your homework. Okay, so UDDI. UDDI is both an organization, it's a consortium of companies called uddi.org. By the way, UDDI, we say things really quickly. Microsoft has taken to actually pronounce WSDL, okay? WSDL. WSDL is what they call it. And SOAP was already pronounceable, right? It's not S-O-A-P, it's SOAP. And so if you ever hear the term WSDL, that also means WSDL. Now, I was on a panel with Microsoft once. Actually, I've been on several panels with Microsoft. And I turned to the guy that said WSDL. I said, what was that? Excuse me, WSDL? And he said WSDL. And I said, oh, okay, good. Well, so what are we going to call Uddi? And he goes, don't do that. So universal description, discovery, and integration. What is UDDI in a nutshell? What it is basically is a set of, it's a registry that is like the Yellow Pages, that allows businesses to describe themselves as a business entity, just like the Yellow Pages would, in terms of kind of a white page entry where you get like the name of the company and a phone number. No big deal. Then a yellow page entry, which is something like I classify my business as a certain type or under a certain category, right? And we're doing this in a smart way. We're not saying get rid of the way business was done on the face of the earth before web services came and hit the streets. We're saying if you already have a way of classifying your business, like using government taxonomies that exist, use that. We'll just give you a technology mirror to that way of describing your company. The important thing is that you're able to describe your company as we classically have known it with Yellow Pages. The new thing is Green Pages. And this is where you actually list the web services that your company is offering to the world. This is the stuff that a program is going to go consume. This other stuff is kind of interesting to humans, okay? So with UDDI, we kind of flesh out the picture of the architecture, the services-oriented architecture. So you now have a place to store services in UDDI business registries right here. So someone who comes up with a service can publish that into a UDDI business registry. Then, if someone comes along and wants to find a service of a certain type, they can do a lookup, right? And then when they find the appropriate service provider, they connect directly to that to that provider. And what this means here right there, it's not buy, it's meant to be bind, okay? So you can bind to the service. If any of you are familiar with Corba, that looks very familiar. That's kind of the broker model, okay? This guy, by the way, you get out of the picture as soon as you find the service provider, and then it's these two talking from there on out. So how this works is several companies have agreed under contract to provide what are called universal business registries. This is kind of like what DNS is for the world of name-to-address resolution that's so vital for the web. If you pull out DNS, the web falls on its face, and yet it's taken for granted. And it's something that proliferates everywhere. When you add a new URL that has an IP binding associated with it, it's figured out across the globe that that change took place because DNS enables that, domain name service. So with UDDI, we're talking about doing the same thing, but what's being proliferated around the world is descriptions of companies. Okay? And how they're proliferated is IBM has some of these things. HP, Microsoft, actually SAP announced a couple weeks ago that they're also offering a universal business registry. So you can register your company, say with SAP, say, hi, I'm Joe's Pizza in Zurich. Now I'm Pizza Hut in Zurich. My son made the observation tonight. He says he knows a little bit of German too, about as much as his dad. He said, now would that be interpreted as a pizza hat in German because of Hut? Yeah, it's like, no. Sorry. It didn't work, John. Okay, so if you registered your business with SAP, okay, the next day that same business description that you put there would be found at the Microsoft UDDI Business Registry and the IBM one and HP. It's sent around the globe, okay? By the way, we force each other to be compliant in this space. This is such a vital backbone for kind of a new notion of a business-centric web that it has to work and it has to be interoperable. We can't just, like cross our fingers and hope for it. We put each other under legal contract to be interoperable, or we come after each other with lawyers. Okay? By the way, we offer this for free. Okay? This is something you can you're going to be late for your next class. So, where was I? Oh, that is free. Lawyers and free, which didn't go well together. But okay. But basically, it is free. It's something that we've said that we're going to offer as kind of a way of bootstrapping a new view of the web, a business-centric view. And this means there are conventions for businesses to describe themselves to each other, and then use each other. Remember I said earlier, it's really business-centric? There are a lot of people who have asked questions about this. Why didn't we use LDAP? Because LDAP is kind of about describing things and about directories. Well, LDAP existed before XML existed. Okay, so that's one difference, is this actually leverages a different set of infrastructure than LDAP does. The other reason is this is a smaller piece of what LDAP is attempting to define. LDAP can describe a directory of anything. This is a directory of business entities. Okay? So here's an example of how that works. A company way down in Australia could offer a business in metals. They would then talk to their local ASP because they don't have enough people on their IT staff to know how to do this. So they talk to a third party who then can register their company in the UDDI business registry on their behalf. That then is proliferated around the UDDI chain of universal business registries. And now marketplaces can discover harbor metals from Australia when they may not have discovered them before. If they do a lookup that says, I need ball bearings, and Harbor Metals is a provider of ball bearings, suddenly they're found, whereas they wouldn't have been found maybe before. So new consumers are suddenly throwing business Harbor Metals' way. Now, as we've gone around and talked about this notion of kind of this, we like to call the Universal Business Registry like the yellow pages in the sky. Okay. There are a lot of people a little concerned about, well, I'm not ready to put my company in the yellow pages in the sky because I don't know how to use this technology yet, and my gosh, what if people start using it and I can't handle the traffic that comes? And companies get really concerned about handling traffic, you know, when you bring up a website. Because if it fails, if the website fails, that's like egg on your face. I don't know if that translates very well, but that's like embarrassing. It's like a reflection on your company. It's like, well, they must not be very good. Their website comes and goes. And so people get a little concerned about that. We know that about companies. And so we were pushing from day one that UDDI, the same technology, could be used inside of a company. Inside of a company, there are different departments. And believe it or not, those departments sometimes use different technology. Okay? And there's politics that goes on inside of a firewall. And so UDDI is a method for many departments to actually leverage each other's work. And here's an example of kind of taking something that the IT staff, and one of the departments has built, taking a commercial piece of software off the shelf, adding web service interfaces into those kind of proprietary worlds, making them available to then be to construct or aggregate larger web services that then could be populated in a local or private UDDI. And then application vendors in one department could actually find this newfangled component that was built out of other web services that exist in your company and bind to it and use it. So the same set of protocols will work internally as well as externally. That's what happened in the first wave of the web too. When you think about HTML and HTTP, a ton of views went into the intranet, a company's intranet. Same technologies, same benefits, two different communities. Okay, so enough on UDDI. Here's some resources on what so you can do further homework if you want. I can't get out of it. We're in the university setting, so I keep going back to that. I'm just glad I don't have homework anymore. So where are we now? The Gartner Group, you mentioned earlier on that they're very in favor of web services. They have a great model of kind of depicting where technology is. It's called the hype curve. So with technology, whenever it comes out, there's this notion of it kind of gets hyped into outer space to begin with. And it hits the peak of inflated expectations. And then eventually hits the trough of disillusionment, which then, if it survives that, moves up the slope of enlightenment to the plateau of productivity. Okay, and they've got this color coding. It's like yellow things are actually accelerating through here fast. The blue things are just kind of, chugging along at a slower speed. So, for instance, they put Java. This is all stuff that Gartner has charted against their own kind of model, their own curve. So they put the Java language over here. About 3 years ago, Java was kind of just coming up over this curve. Okay? We think it took off when it hit the server side, of course. It took a while to convince Sun Microsystems to move it to the server side. I was a big part of that at Novell. And that's where I met my IBM friends. We were all working in the same direction. So where do we put web services? We put it right here, basically just about ready to peak out in terms of the peak of inflated expectations. Okay? That's why I'm here giving you a talk on this, okay? So that you can get all excited about it. Okay? And that's definitely happening. The world is very excited about it. As I said, IBM thinks this will have a bigger impact on the planet than the first wave of the web did. That just makes me like shake inside to think about, no way, because the first wave of the web was huge. What's this going to accomplish? There's another curve that you may be familiar with. Jeffrey Moore wrote a book called Crossing the Chasm, and he talks about the stages of adoption. Typically, innovators are kind of like the geeks in a company whose job it is just to go try out new toys. They kind of pick up new technology and play with it. And then if they don't like it, they throw it in the bit basket and it doesn't go anywhere. But if it goes further, it's early adopters and kind of pilot projects are taken on. And these are the people on the so-called bleeding edge of technology. They're the ones who are out there with early technology and all the hiccups that come with early technology. Typically what happens is things fall off and into the chasm. You've probably heard this model before. If they don't, eventually they get picked up. If they don't fall off, they eventually get picked up by what's called the early majority. These are the people that kind of wait for those early pioneers to kick the thing around and make sure it works, right? And we'll finally use it. They're a little more conservative, right? And then the late majority are the guys who say, they're not going to innovate anything, but they will go do it if their neighbor company did it, okay? They'll pick up on the technology. And then there's the laggards, who are the guys who just aren't with it at all. So where are web services in this model? Clearly, and there's pretty strong agreement that it's very early, the early adopter stage. Okay? So we're doing a lot of pilot projects ourselves. At IBM, we've got a program called JStart, Jumpstart, and that takes any early emerging technology that IBM has and works with customers to do pilot projects so they can actually check it out. It actually serves a purpose for the vendor, too. The vendor gets feedback and says, oh, you mean we didn't do the SOAP right, SOAP header. It's not interoperating with Microsoft. Okay, we need to find out and fix that. Okay? So there's agreement that approximately 75% of the world thinks web services is important and they're going to be doing things. Here's some examples of how it's being used. In the travel industry, there's a company called Galileo. These are the guys who, when you go to plan a trip, you're ferrying, you work out with a travel agent where you're going to go. The travel agent typically is then working with Galileo behind the scenes. So they have 42,000 travel agents who work with 511 airlines. Actually, it's probably 510 now because of and 37. Sorry. Hey, you produce a lot of good things in this country. Airline wasn't in the cards. Okay, so 37 car rental agencies, 47 hotels, and so forth. You get the idea. Each one of those entities, those businesses, guess what? They've all elected freely to use whatever technology they damn well please. And Galileo tries to get that all to work together. So this is a perfect example of the need for technology that embraces heterogeneity, web services. So IBM's been working with Galileo to actually convert their whole reservation system into using web services. So it's the freedom then for these folks to all kind of stay with the technology they have. This is a further example of that. So behind the scenes, what you could imagine is a traveler talking to a travel agent who then talks to an airline. All that stuff that's done with phone calls and faxes and things like that today can be done from one program talking to another program and then orchestrating the results, all being automated. Okay? That's what this is enabling. Another example is in the healthcare industry. Interpro Global Systems is a system integrator in the Midwest of the United States. And what they've done is in the Midwest there's an Independent Physicians Association, IPAs. That's groups of doctors, basically. And then there are healthcare service providers, hospitals, labs, pharmacies, and so forth. And then insurance companies. Now that's the healthcare industry. Again, they all use their own technologies, thank you, and they don't want anyone forcing them to use a single kind of technology. And yet they need to work one with another. How do you automate all of that? Well, with web services, they're now coming up with a common notion of a patient record, a common notion of a lab order that can be passed across all of them, and then this is all automatable, and it speeds up things. So that way you can get your broken arm fixed faster. Also, another example is an independent software vendor or an ISV. In this case, it's Velocigen. This is a company that's based in San Diego, California. And they're one of the early new vendors to kind of come into existence in the space of web services. They are a web services-based company, and they give you a tool to actually help you build your own web services or convert existing entities into web services. So what's next for web services? What's needed to cross the chasm? Well, first of all, the fact that the world's heterogeneous and getting heterogeneouser means that the demand for technology that spans that will only get larger over time. There will be continued progress with open standards. We're working hard in the areas of reliability and security. And like on any frontier, any new frontier, it's so important to get tools into the hands of the early frontiersmen so they can kind of clear the forest. And so IBM and Microsoft are doing this along with other companies in helping you to author web services or convert existing assets into web services. The appearance of an aftermarket. So now there's a whole new opportunity that didn't exist before this technology, and then people can come in and make further money around it. That's a good indicator. And then simply the growth of web services themselves. It's kind of like the web happened, it virtually happened overnight, but it happened with each person that was authoring a website coming up with an href, the pointer, the link between one document to another website. Okay? And so the web was built one href at a time by humans. The technology enabled them to do that, but they're the ones who populated it and went out and described it. Same thing with web services. Web services themselves are those callable interfaces. And so as more of those mount, and it looks more and more appealing, more and more people will step into it and consume those services and then be called themselves to describe their own businesses using web services. What's going to change? Well, clearly the area of packaged software, especially packaged software that is platform dependent, I say that's just going to start to disappear. The biggest indicator of that is Microsoft itself. Microsoft is moving to a software as a service model. And if Microsoft goes and does it, then chances are a great deal of the world of software vendors will also go do it. So what rises in the place of packaged software is service software and the supportive infrastructure. Over time, Okay, good. And the area of professional services, system integrators and consultants, some people are concerned that web services, the technology is going to replace these guys. Like, you know, they're going to be out of a job because now everybody, your average Joe and their mother, could come in and actually do software integration because, gee whiz, SOAP and wsdl and things like that enable you to do it. It's true that a lot of their functionality will be replaced with some of this technology, make it easier for everyone. But guess what? There are going to be more people jumping into business automation than we've ever seen before. And you could think of each company as unique as a snowflake, okay, in terms of what they need to describe if they're coming up with company APIs. And that means there's going to need to be a herd of people, of cattle, of system integrators. Sorry, not to say, you know, you could go out and be a system integrator and be revered in other places other than just India. But no, sorry. It's getting late. So, so there will be more people needed to actually assist in that integration effort. So in a nutshell, it's going to, you know, the top thing's going to go down and the bottom thing's going to go up. Here's a look at the emerging web services stack. This is what IBM and Microsoft have agreed on, and a lot of other companies have rallied around this view. It used to be that you needed at least the TCP/IP stack on any node that wanted to participate in the web. What we're saying is, beyond, you know, TCP/IP, and then of course FTP and HTTP, you now add in SOAP. I'm going to do this talk in Italy next week. SOAP. And then wsdl and so forth up this stack. And so this is what you're going to find on any node that wants to participate in the web with web services. WSFL is something we haven't talked about, but it talks about, it's dealing with a higher level aggregation, so the notion of workflow. Okay? It actually stands for Web Services Football League. No, it's Web Services Flow Language is what that stands for. And then we have to deal with security, with management, and quality of service across every one of those layers of technology. But that's kind of a preview of things to come, of what we're working on. I won't go into details on that. So our strategy at IBM is, number one, go out and lead and participate in the standards process. We're absolutely doing that. The other is, let's get this code, the results of that work, into the hands of as many people as possible, as quickly as possible. We're doing that. We accelerate that with open source, by the way. And then we add this technology into our existing products. So our entire software portfolio at IBM has been upgraded in the last year to include support for wsdl and SOAP and Uddi. And then we go build customer solutions. Okay? Real quick, Big Blue changed. When I was a kid growing up in California, a lot of my friends' parents worked for Big Blue. And I swore back then, I will never work for that company. Actually, obviously, I had to take my words back because something changed. The reason I felt that way before is the early days of IBM, it was kind of the walled fortress approach. We know how to do technology, thank you. We don't need to talk to anyone else. If you want to use our technology, buy our products, and it will work. And it worked. Okay, it worked. Big Blue made it. It was like the answer in town. Okay? And I like to call that the Knights of Ni, kind of from Monty Python's Holy Grail. But the not invented here, the Knights of Ni. Okay? That's what IBM was in my mind. Okay? And then IBM started the revolution of openness with the IBM PC in 1981, probably before a number of you were born. And by the way, that question mark should be an arrow pointing in this direction. Same with this. I apologize. But we published the ROM BIOS, kind of the description of how the computer actually worked. And that allowed the PC revolution to take off because the clone market happened. IBM had no idea what we were doing. We were in the mainframe business, and suddenly this thing called the PC took off. And most of IBM, who were the Knights of Ni, said, ooh, that's bad. And Microsoft ran away with the ball and the game, and the world changed. Okay? IBM finally came around to like getting it, okay, and realized approximately 1994 that instead of fighting NT with OS2, OS2 is better than NT. No. We quit saying that. We said, you know what? If you've got NT, we'll use it. Our software will run on top of it. We're not throwing in the towel. We still think OS2 is great, okay? But if you've got NT, we'll let our stuff work with it. Then the next thing, and this is the one that I was at Novell at the time, I kind of went, oh my gosh, IBM has changed. They embraced technology from one of their arch competitors, Sun Microsystems, in the form of Java. Now, Java was, I alluded to this earlier, Java is a cross-platform thing coming from a company that has one platform, Sun. It didn't make a lot of sense. IBM had a jillion platforms. And so they needed Java more than anyone else on the planet, and therefore embraced the heck out of it. Okay? The next thing was kind of the web and open standards. That made sense to me. But when IBM embraced Apache and open source, my young man's vision of IBM was totally obliterated. It's like, wait a minute. The biggest patent portfolio owner on the planet, the company with the lawyers, is embracing free software with a bunch of wild-haired programmers out in the world? What? This is not the stodgy three-piece suit people that I knew. I liked those wild-haired programmers. And so when I saw IBM doing that, I said, maybe this is a different company than I thought was around before. And then we embraced Linux. IBM actually invested $1 billion in Linux last year. Okay? Amazing. The reason we did that is we're saying the standalone OS doesn't make sense anymore. It's not the battleground. Who cares what OS you use? Use whatever OS you darn well please. What matters is how that OS and that platform connects to the rest of the web. So I saw that change at IBM, and I said, yeah, when they offered me a job, I said, absolutely, I'll come on board. After all, Novell was kind of going downhill quick. Forgive me, my Novell compatriots, go for it. So there's now this new IBM that drives openness and standards. Okay? Okay, we're very close to the end of the talk. We've led with many early implementations. We get it out on AlphaWorks, as I indicated earlier, and then we work with the standards bodies, and then move it to our software products. That's kind of the flow of things. I won't spend time on this, but that notion of open technology, if you believe in open technology, you believe in an open and much larger marketplace. IBM believes in that. Whatever money we lose in not getting software sales, guess what? More opportunity to sell hardware, more opportunity to sell other kinds of software than the free stuff, and more opportunities to sell services, professional services. By the way, this is what IBM's been known for over the years, is the ability to show up and say, how you doing? My name's Sam. I'll be with you for the next 10 years, assisting you in getting your business to be automated, putting an E in front of your business. It takes a long time to put the E in front. So what's in it for us? Where are we coming from? Well, it'd be great if it were just a world where we were just doing this because we love the planet. We do, but there's also some selfish motivation. As I've indicated, we're going to sell more of our software, more of our hardware, and more of our professional services. Okay? And we tie that up in a tidy package called dynamic e-business. We've been doing e-business as kind of the main strategy at IBM for the last 5 years. That changed now with web services. We actually did a big change. We added the word dynamic in front of e-business. And that's because that's what web services enables you to do, is have freedom of choice. Okay? It's different. Microsoft has a thing called .NET. And .NET is their name for this. It's the name of an architecture. We have an architecture behind this as well, but we're not worried about getting the world to know the name of our architecture. We tried that route before with SNA and SAA and the IBM Blueprint. Those were all named architectures. So instead, we're moving to more of a, well, what's in it for business? And that's the name of our entire effort. Okay, in conclusion, web services, second wave of the web. What's the big catch word for it? Integration. That's what it enables. The huge shifts that await us are the software industry, the rise of infrastructure and services, and the fall of platform-specific packages. We're going to get back to real and reusable value. So, I thank you. These are some resources. Actually, one of them listed is a toolkit CD, which actually gathers up a bunch of stuff that we've got on AlphaWorks and puts it in a convenient form so you don't have to download, all night to get to that cool stuff. So I've got a handful of those CDs up here that I'm very willing to just give out to you folks. Okay? So at this point, and by the way, there's my email address if you need to get a hold of me. It's just my initials, SHH.